The mountain pine beetle has been attacking forests for millions of years. This cycle is different. This one is unprecedented, both in its intensity at a site and also in its geographic extent. This thing goes from New Mexico 1,000 miles north to the Yukon territories, from the Front Range of Colorado to the Pacific Ocean. This thing is already 10 times bigger than the second biggest epidemic in history. And people are wondering, why is this one so big?
Coloradans want to know what the next forest will look like over the next 100 years. What will this turn into?
Scientists at the University of Colorado are working to find answers to these questions. Jeff Mitten and Scott Fahrenberg are trapping pine beetles and documenting attacks on trees just east of the Continental Divide. They are finding that longer, warmer growing seasons and persistent drought make the trees more vulnerable to pine beetles. Trees are killed as female beetles bore through the bark to lay their eggs.
Scott, look, a bark beetle is just starting a new hole now. I just saw the bark beetle go into that hole.
Yeah, I can see him too. There's another one here, Jeff.
When beetles attack a tree, it's a green tree. When they mass attack it, within a few days, water is no longer moving up, carbohydrates are no longer coming down. It's effectively dead, but it looks perfectly healthy for another 10 months to 12 months. The following summer in July, it begins to turn red like some of the trees around us. The tree needs water for everything, but one of the primary uses of the water, and certainly the primary defense, is that the water is turned into resin. And the resin is stored in resin canals in the bark, and that is what the bark beetle severs when it goes tunneling into the tree.
Here we go, Jeff. Look at these darkened up, ready to fly.
If the tree is beautifully healthy, an enormous flow of resin will actually push it out. Foresters say it's being pitched out. It's pitch tossing the beetle out. That's the defense of the tree. Some people have asked, how many bark beetles does it take to kill a tree? And the answer is, it's incredibly variable. If a tree is healthy and it's got all the water that it needs, there are documented cases where 2,000 beetles will hit a tree. All of them get pitched out, and the tree survives the entire attack. If it doesn't have enough water, the resin pressure goes down. It can only put out a little bit of resin. The beetle has no problem with that, and the beetle calls in more and more, and they collectively sense we've won, and that tree is a goner. Does drought or climate change have something to do with it? It certainly does.
Jeff and Scott have compared their observations of beetle activity in May and June with records from the University of Colorado's Mountain Research Station, where climatologists have been closely tracking daily temperatures for decades.
It gets warmer and drier during the summers now. The temperature is particularly changing in spring, before July 1. And so if it's hotter and drier, this is a more susceptible tree. So then instead of perhaps 800 beetles needed to kill this tree, perhaps only 200 are needed to kill it. If it gets really drought stressed, a couple dozen can kill it. right, let's see how it goes. In addition, one of the consequences of the change in summer temperature is the bark beetle life cycle has really changed. 2, 3, and 4 decades ago, the bark beetles started coming out in July. There was a pulse of them the second and the third week in August. Seeing 1, 2, and their offspring would get out of the tree the following year at about the same time. A female bark beetle can lay about 60 eggs. What Scott and I have found is that the bark beetles now are starting much, much earlier. This year, when did you catch the first beetles?
May 22nd.
May 22nd, instead of the first few coming out in July. And that's fully 2 months earlier. Furthermore, we catch them later. We catch them as late as September 20th. So the season is fully twice as long as it used to be. And we saw last year that the ones that can start early, their offspring are out in August, not 12 months later, 2 months later. As a consequence, a female that can start in June has 60 offspring, and then her offspring each have about 60. So that's 60 offspring plus 3,600 in a year. And so the season is much longer. The beetles are now starting in May instead of in July. So the reproductive potential is exponentially greater than it's been before, because at least some of the beetles are pulling off 2 generations per year. We think this is one of the reasons that this epidemic is unprecedented in scale and intensity. Within about 5 years, almost every large lodgepole in the state will be killed.
The mountain pine beetle has affected more than 3 million acres of forest in Colorado.
I'm studying the regeneration that's following this intense mountain pine beetle outbreak. Even though we have the death of a mature forest, we want to know what is going to help create a new forest. We are not seeing a large number of new lodgepole pine seedlings coming in the understory of this dead forest. What we are seeing is a subalpine fir and species that grow better in the shade, which will be a very different forest than the pine forest we're used to. We will also most likely see an increase in aspen in many areas where aspen is currently existing. It could take 30, 40, 50 years for those trees to reach the height of the current forest. However, it is a different forest. There will be logs strewn all over the ground. I think that soil moisture and climatic conditions will be the most influencing factor in the regeneration of our future forest. We're in the midst of a long-term drought, a very dry period. Drought conditions are not favorable to any tree species. And so the lack of regeneration of tree seedlings could largely be due to extremely dry conditions.
I think one of the things to reflect upon is that we are no longer talking about the possibility of climate change. This began decades ago. And now what we're seeing is one of the major changes. We're seeing an epidemic that is just completely unprecedented. We talk a lot about stopping the increase in carbon dioxide, but as of yet, we haven't done anything.